Hello and welcome back. So, in the previous videos, we have been going over what parallel lines are, what skew lines are, angle relations. And that was all day 1. Day 2, we talked about the theorems and the postulate that come from parallel lines. So, given parallel lines, here are things you can conclude. Today, we're going to be going backwards. We're starting with angle relations and we're going to parallel lines. Thus, we are proving that the lines are parallel. Thus the title. I do want to make a small note. This is the online day. Okay, keep that in mind. This is chapter 3, day 3 of this chapter. This is the book section. We did skip a few sections. We may go back for them. They were basically a graphing review, and we can do that at a later date. So we went from section in the book 3.1 to section 3.2 to now section 3.5. Okay? We just wanted to make that clear for all of those trying to follow along in the book. Let's get started. So this is a list of the angle postulates and theorems. Okay, you should already have all these down, either in your notes, on your postulates and definition page, any of those. So these were all theorems and postulates we learned last time, and just to refresh the memory, all of these have the exact same pattern. You're told that if the lines are parallel, then the angles, whatever they are congruent. Okay, if the lines are parallel, then the angles are congruent. Or, as we get further down the list, if the lines are parallel, then the angles are supplementary. Okay, the point I'm trying to make here is that in all of these postulate and theorems, you start with parallel lines, and then you go to your angle facts. Okay, but what happens when we reverse an if-then statement? Okay, let's just think about this. See if you can remember. If I have a statement that goes P then Q, this is a conditional statement. What happens if I flip it and go P or Q then P? All right, this variation is called the converse, and converse has its own purpose. Say hello to the converse angle and postulate theorems. Okay, now in this postulate and these theorems, instead of going from parallel lines to angle relationships like the other one did, all of these, if you notice, go from angle relationships to parallel lines. So if the angles have a certain relationship, if corresponding angles are congruent, then lines are parallel. If alternate interior angles are congruent, then lines are parallel. Okay? If alternate exterior angles are congruent, then lines are parallel. I'll do one more. Okay? If same side interior angles are supplementary, then lines are parallel. Okay, so the pattern has been reversed because it's a converse. Okay? Instead of going from parallel lines to angles, we are now going from angles to parallel lines. The purpose of this is because in math, if you can go forward, you can go backwards. Okay? If we can take parallel lines and prove that angles have a certain measure, then we should also be able to take angle measures and come to conclusions about the lines that create those angles. And that's what we're going to be doing in this chapter. We are going to be starting with angle measures. We're going to be given that certain angles have certain measures. They're either congruent or supplementary. And then we're going to have to draw a conclusion of whether or not those lines are parallel. Okay? So it's really important on these to pay attention what information you're given, because that's going to determine what theorem or postulate you use. If you're given that lines are parallel, then you're going to be using all the theorems on the last slide, because those are given parallel lines, and then you conclude with angles. However, if you're given angles, you would use these because these are given angles and you're proving parallel lines. Okay, let's do some practice on this. So let's start things off with the proof. Because like I said in the last slide, the whole purpose of this, or one of the purposes of this, is when we're given angles to prove parallel lines. So we might as well get started with the proof. Now, when you're doing these, just like with all proofs, keep an eye on what you're given and try to connect what you're given with what you're trying to prove. So let's look at our picture. We are told that angle 1 is congruent to angle 2. Now I can hear you guys through the camera. Miss Stockton, those are alternate exterior angles, therefore those lines must be parallel. Okay, yes, they are alternate exterior angles. However, we are trying to prove that theorem. Therefore, we can't use that theorem. Okay, so when you're trying to prove something, you can't use it in the actual proof. That's like using the word in the definition. But very good catch if you did see that immediately. Now, even though I can't use alternate exterior angles theorem right here, I can use any of my postulates. Okay, and there's only one postulate that I have, and that's the converse of the corresponding angles postulate. All right, and that one states that if I have congruent corresponding angles, then the lines are parallel. Okay, so as I look at my picture, I'm going to see if I can recognize anything else, but I'm going to be trying to go for this. All right, I'm trying to find corresponding angles that are congruent. Looking at my picture, and I see that 3 and 2, angles 3 and 2 are congruent, and they're congruent because of vertical angles. Okay, and then as I'm looking, I see that angle 1 and angle 3, it worked out that they're congruent. And that's awesome because angles 1 and angle 3 are corresponding, and I have just proven that corresponding angles are congruent. All right, so that means I can eventually prove that the lines are parallel. That's going to work out. So let's take all of those notes and put them into the actual proof. Let's organize them. So first statement is always given. There it is. Second statement, I know that angle 2 is congruent to angle 3 because of vertical angles. Well, the vertical angle theorem, to be exact. Next, I know that angle 1 is congruent to angle 3 because of the transitive property. Okay, if 1 is congruent to 2 and 2 is congruent to 3, then 1 must be congruent to 3. Now, it can't be substitution, remember, because there is no substitution property of congruency. Okay, so it has to be transitive. Then, last but not least, I can say that line L is parallel to line M because of the converse of corresponding angles postulate. Okay, remember, I can't say alternate exterior angles theorem because that's the one I'm trying to prove, or the converse of alternate exterior angles theorem, because that's what I'm trying to prove. However, angle 1 and angle 3 are corresponding angles, and in my proof, I showed them these two corresponding angles to be congruent, and therefore I know the lines are parallel. And now I'm done, and I can sign off, and I have proven the converse of alternate exterior angles theorem to be true. Okay, now I can use this theorem on any of my other proofs, because I know it to be true. Now, I mentioned this a few class periods ago, actually last chapter when we started going over proofs. There's more than one way to do a proof. Okay, the way we've been doing it so far has been called a two-column proofs because of the two columns. However, another way we can do proofs is called a flow proof. All right, and this one is more of a visual. Okay, so some people really like the flow proof because it visually connects the ideas, whereas a two-column proof seems more random in how things get placed. So a flow proof, the arrows show the logical connection, like I just said, between the statements. Where there's an arrow, there is a logical connection, okay, a logical thought point. I am given this, therefore this. I have this, therefore this. And those therefores are always marked with arrows. Okay? And then the statements are written in the boxes, and the reasons are written underneath the statements. All right, so on this one, we are going to prove the alternate interior angle theorem. Okay, so to use my shorthand that we've been doing in class, the alternate interior angle theorem. So in this proof, we are given that angle 4 is congruent to angle 6. So I know angle 4 is congruent to angle 6. Again, I can't say alternate interior angle theorem because I don't know those lines are parallel. But I do have, and I'll write this down somewhere, I do have still the converse of corresponding angles postulate, and the one we did last time, the last slide, the converse of alternate exterior angles theorem. Okay, I have these two, and I can use these two to prove alternate interior, or to prove the converse of the alternate interior angles theorem. So what I'm going to do is, as I look at my picture, I'm going to try to find a way to get to one of these two theorems. Because once I have one of these two, then I'm good. The lines are parallel. All right, so as I look at my picture, I notice that angle 4 is congruent to angle 2 because of the vertical angles theorem. And then as I look a bit more, I see that angle 2 is congruent to angle 6. And the nice thing about that fact is because angle 2 and angle 6 are corresponding angles, and that means I can use my corresponding angles postulate. Okay, so I'm going to go in that direction. So I already have my given. My given is that angle 4 is congruent to angle 6. So I'm going to put down here that angle 4 is congruent to angle 2 because of vertical angles theorem. Then I'm going to say that angle 2 is congruent to angle 6. And I can say this because of transitive, or the transitive property. I'll spell it out this time. And then because angle 2 is congruent to angle 6, I can say the lines are parallel because of the converse of the corresponding angles postulate. Okay? Sign off. Always sign off. It's still a proof. And we're done. See? Now, another way you could have gone after this proof is you could have seen that 6 was also congruent to 8. And therefore 2 and 8 are alternate exterior angles. And so you could have tried to prove this using the converse of alternate exterior angles. And that would have been equally as valid. This way was just a little simpler and a little easier to show you in the flow proof. Now, one thing I want to mention before I leave this slide. Notice how when I was talking, when I was writing, I always used the word converse when I was describing these theorems. In fact, sometimes in the video I had to correct myself because I forgot to say it. All right, but then I went back and I said it. It's the converse of the alternate interior angles theorem. It's the converse of the corresponding angles postulate. The converse of the alternate exterior angles theorem. I'm not just saying that first word because I like it. It's very important that you have the converse up front. And the reason is because that's what we're doing. Okay, geometry is about explaining why and how things work, which means you have to be careful with your language. In this proof, this one and the last one, we were proving the lines are parallel, which means we were given angles and we were proving parallel lines. The theorems that do this are the converse theorems. Okay? If you tell me on a proof that these two lines are parallel because of the corresponding angles postulate, that's not going to make any sense, because by definition, the corresponding angles postulate is given parallel lines. Okay, you start off with parallel lines in that theorem, or in that postulate. Therefore, why would you be proving parallel lines using that postulate? Okay? So you need to be very careful and very deliberate that whenever you are proving parallel lines, you are using the converse, not the original postulate or theorem. All right, let's move on. Enough of proofs for now. Let's do some actual math problems. So here, instead of being given that I have parallel lines, find x, I'm told the reverse. I need to find the value of x to make the lines parallel. Now, I grant you the questions are very, very similar. However, sometimes the wording does manage to throw people off, so please make sure you pay attention. The process is still the same on how you set these things up. First thing you gotta do is figure out what your relationship here is. These two angles are same side interior, and same side interior angles need to be supplementary for these two lines to be parallel. And I know that because of the converse of same side interior angles theorem. So what I'm going to do is I'm going to set this up so that when added together, these angles equal 180, because that will guarantee they fulfill my theorem and that the lines will then end up being parallel. Then once you got it set up, all you do is solve. And x is equal to 30. Now we can double check this by plugging 30 back into our expression and then seeing if that value and this value are indeed supplementary. So let's go ahead and check that. I have 2x plus 9. Okay, so that's going to be 2 times 30 plus 9. So 60 plus 9. This is going to equal 69. All right, and then if I add 111 to this, it does indeed come out to 180. You can all start cheering now. The problem is correct. X is 30. All right, let's do one more. Okay, same, well, not same exact problem, but same exact process. Okay, we need to recognize what our angle relationship is, and then write an equation that forces it to match the theorem. So what value of x will make u parallel to v? Okay, these two angles are alternate exterior angles. So if the lines are going to be parallel, these two angles need to be equal to each other. Okay, because of the converse. There's an S in there somewhere. Yeah. Of alternate exterior angles theorem. So I'm going to set these two equal to each other. And then you solve from here. Minus 9 minus 9x plus 10 plus 10. And then you have 11 is equal to x, and that is the value of x that would make these two angles congruent, thus satisfying the converse of alternate exterior angles theorem. Well, this is all the time we have for today. This is the end of the video. Please let me know if you have any questions, and I'll see you next time. Bye.